So before the next talk, I'd like to ask you to see a show of hands for whoever used Facebook on Android today. Who is using it right now? I know some of you are. So this is what's very cool about it, is that today we're actually gonna find out how it's built from Simon Stewart, who's also a core member at Selenium. So I'd like to welcome him on stage. Simon Stewart, Facebook developer.
Thank you very much for that introduction. Before I begin, can I just ask, how many of you are actually software developers? Can you? Oh, good. I can use technical phrases, and you're not going to be too scared. I can use technical phrases, and you're not going to be too scared, right? Excellent. And a clicker. I can get through my slides now. That's probably a good thing. So, yes, I am a software engineer at Facebook, part of the infrastructure team, and the focus of my job is around developer efficiency and effectiveness. How do we enable our engineers to go as fast as humanly possible? So there's a challenge. In the mobile space at Facebook, we have a code repository with upward of 100,000 commits in it. There's more than 150,000 files tucked away in there in various places. And we've got more than 300 engineers banging away on this single code base, writing code. And what we'd like to be able to do is we'd like to be able to go as fast on mobile as we do on the web. On the web, we push twice a day. So there's a completely new version of Facebook pushed to every single piece of our infrastructure twice a day. How do we come even close to that when developing on mobile, and particularly taking a look at Android? Most importantly, there's no single Android team. So we can't just say to people, you guys, we'll lock you in a room, we'll give you lots of sugar and caffeine tablets, and you just write code as quick as you can and try and keep up with everyone on the web. That's not how we've organized our teams. The way we've tried to organize things is that feature teams own their feature. So they own their feature, and the Photos team own photos, for example, not just on the web, but on iOS and on Android as well. And on the mobile web for the lower-end devices. Same applies to Newsfeed. Same applies to any particular feature team that we have at Facebook. We try and let people own their own code. So, how do we move fast? It's one of the slogans at Facebook. It used to be move fast and break things, but people used to get the wrong idea about what we meant when we said that. We didn't mean like break people's user experience. We just meant like don't be afraid to fail. So now it's move fast and build things. Key thing, the most important thing, we want to be able to build fast. We want someone to have an idea, get their idea into code, and get their code onto a device and in users' hands as quickly as humanly possible. How do we do this? The first thing that we do is we have to have our source code stored somewhere. Everybody uses Git in the Android tree for developing their code. And there are two branches that we care about. The first one is master. Master contains the latest, greatest version of everything that everyone's been working on. It's the tip of tree. Whenever we land a change, it always goes into master. The problem is that, hold on, there were lots of engineers in the room. Can any of the engineers who haven't written a bug ever just raise their hand? Yeah. No hands whatsoever. Everybody writes bugs. It's just the nature of the beast. And so what we do is when you've committed your code into master, we hook up a series of continuous builds that verify that, first of all, it still continues to compile, which occasionally it doesn't. And then it runs through a series of automated tests, end-to-end tests, stress tests, and things like that. When we're relatively confident that the code that's landed is going to work and be as effective as it should be, we then tag that as stable. So when you're starting to work on a new feature, you just branch from stable, you do your work on that feature, and it's all good. The code is organized in a single tree. So Facebook have more than one product on Android. If you wanted to go to the Google Play Store now, you could download Messenger, you could download Facebook, you could download Instagram, and there are various other bits and pieces. I think there used to be camera but that's been now rolled back. All of that code lives in a single tree. And one of the advantages of having everything live in a single tree is that you can share code really easily between different projects. So as a hypothetical example, let's imagine networking or UI components or something like that. Rather than having each individual team have to try and solve the same problems or not encounter problems that someone else has run into and fixed, rather than having to do their own thing, it's really easy to share that common code. Now, there are systems that allow you to do this in the open source world. Perhaps some of you use Maven and you sort of modularize your code base and stuff like that. The downside with that is you end up with a sort of fragmented code base, and creating a new module is incredibly painful. By having everything live in the same tree, we can very quickly and very easily create and extract new modules and share code around. No one likes to check in a bug, so before any line of code lands in our tree, we always go through code review. That means that every single line of code in the Android code base has been seen by at least 2 engineers, the engineer who wrote it and the engineer who rubber stamped it and allowed it into the code base. This here is the code review tool that we use. It's called Fabricator. If you're interested in doing code reviews, definitely Fabricator is worth a look. It's open source. It's written in PHP, so Fabricator is spelled PH, and then the rest of Fabricator. And you can see here that one of my colleagues has put up a code review and written a test plan, and the test plan appears to, that's the purple section, and it appears to be more than just make sure it compiles. And then someone's come back with a couple of comments, and then the green bar down at the bottom says, OK, this is good. You can ship this. You can land it. The killer feature of Fabricator, if you've never done code review before, are the GIFs that you can put in, and we're allowed animated GIFs. So you can do snarky comments to people's bad code in an animated way. I love that feature. It's the killer feature of Fabricator for code review. So we've got this lovely code base. It's really easy to extract new modules. It's super simple to share code between projects. But it's also, by definition, then really easy to create tight coupling between packages. If you're a software developer, you know that tight coupling is a bad idea. So how do we try and prevent that? How do we encourage looser coupling between the various components that we have? Now, the classic computer science engineering answer to that question is to use interface implementation separation. That is, you've got an interface that represents the basic concept of what you're trying to model, and then you've got a concrete implementation that describes how that's actually implemented. We ripple this through our code base, this sort of style of programming, using something called dependency injection. If you've never heard of dependency injection, definitely worth having a look at it if you're a software developer. If you're not a software developer, it's still quite interesting, but it's probably not going to be terribly useful to you. Yes, so we use dependency injection, particularly constructor-based dependency injection, all the way through our code base. Now, our code base is several years old, but if I was starting again, I think we'd be taking a look at using something like Dagger by Square, which is open source and which does a really nice framework for Android that avoids some of the reflective lookups and things like that, which kill performance on Android. Ah, yes, reflection on Android. Try and avoid that. If you want your application to perform well, Dalvik just isn't set up for it. And so our dependency injection framework tries to do as much static setup as possible using direct calls, rather than trying to infer everything at runtime. So we've got this massive tree, and it contains dozens of projects and little useful components and things like that. And then we came to try and build it. Now, back in the day, the recommended way of building software for Android was to use a build tool called Ant. It's now Gradle. That's the new hotness in the Android space. But the problem with Ant, and indeed with Gradle, is, it's kind of slow. And we wanted something that was going to be incredibly fast to do a build, that would support particularly incremental builds that were incredibly rapid. Most of the time, the engineers are working on a feature. They're just changing a couple lines of code and trying to get that feature onto a device so they can check that it works the way they thought it would. We'd like to be able to support ad hoc build steps. No build tool on the planet supports doing all the things that everyone wants to do all the time. So, it would be nice to be able to extend it. We use an IDE. We use IntelliJ extensively at Facebook, which is a really good Java IDE. PHP Storm, which was mentioned in the previous talk, is based on the same core. It's by a company called JetBrains. It's fantastic. Go and download it if you've not had a look at it and you write Java. But we want whatever build tool we use to make it really easy to also pull in our source code and use our source code in an IDE. And what we wanted to do was avoid boilerplate and overhead when creating a new module. Like if we'd chosen a system like Maven, for example, each module that we created would need a certain amount of ceremony. It would need a new top-level POM, it would need the source main Java directory, source main test, and so on and so forth. And then you'd need to wire things up, and it would, just an awful lot of overhead just to extract a single package. So we created a tool called Buck. Buck is an Android build system. It's got 3 major concepts in it, which are pretty obvious if you sit back and think about, like, how would I want to build some software? The first thing is a build rule. And a build rule is simply a way of specifying a series of input files and their dependencies and some other information and generating an output file. You can think of it as a function. For the same inputs, the same output comes out. And it doesn't matter how you organize those things, the output is always the same. We specify the build rules in build files. Good gosh. So projects like Maven, for example, tend to have a top-level pom.xml. With Ant, you've got a top-level build.xml, and you may use recursive Ant, which places build.xml files throughout your build file, and life gets incredibly complicated at that point. With Buck, each module that you want to compile has its own top-level Buck file. So our tree basically has 1 Buck file per directory. How do you refer to build rules within a build file? Well, use a build target. That's like a pointer, a label to a build rule in another file. And a build target looks like this. The double slash I like to read as from the beginning, from the root of the project, from the root of the repository. There is a directory, javacom Facebook share, colon. Within that directory, there is a Buck file, and within that Buck file, there is a build rule named UI. What does UI look like? It looks a bit like this. So this is what a build rule looks like. It's got its name, it's got a series of sources, in this case, everything called Java underneath this directory, and it's got a series of dependencies. And you can see those dependencies are listed as build targets. Now, the nice thing here is that even if you don't have the faintest clue how to build Android software, you can just take a look at this file, and you can see where its dependencies are, and you can understand how our code base wires itself up together. And finally, visibility. You don't want everything available to everybody, because otherwise your brain just explodes from the complexity. So we allow people to limit visibility. By default, everything is private. So we take all these build rules that we have, all these build files, and we build a directed acyclic graph. That's a graph that doesn't have any cycles, and it's got edges that point to each other. And then you can do some analysis on that, and you can go like, oh, look, there's a subpart of the graph here that we could build independently of everything else. And you can see here, AL, up at the top there, has 2 dependent subgraphs that we could build in parallel to go faster. And that's what we do, actually. We build everything in parallel. Your modern laptop contains, there's a gentleman sitting on the front row, excuse me. How many cores has your Macintosh laptop got? 4 cores, and it's probably got hyperthreading, right? So it can simulate 8 cores at the same time. Now, I remember when I started doing software development, which wasn't that long ago, 1 core was the normal thing, and if someone was super wealthy, they might have 2. And worse, you've probably got an SSD in there now as well, haven't you? Yeah, of course, was the answer. Nobody has little spinning disks of rust floating around in their computer anymore. Like, nobody does have a hard drive, do they? Not in the old-fashioned sense. One poor person who's smiling and laughing. I'm so sorry. So a modern build system, if you were to create one, would take advantage of the fact that everyone's got SSDs with super fast read writes, and in particular, random writes are really quickly. You don't need to wait for the disk to spin and the head to find the right place. You can just send it there and it works. And they've got multiple cores. And Buck is designed to take advantage of both of these things. So it automatically parses the graph and runs as much stuff in parallel as it possibly can. And it writes to the SSD. It's also designed to take advantage of distributed caching. We use Cassandra at Facebook, and it's possible for someone to do a checkout of the build and have built the entire part, the whole of FP4A, the Android app, in approximately 1 minute. Now, without all the features and the hooks and the things we have, it would take about 20 minutes to get that far. So, I mean, we've slashed build times using this infrastructure. If you're interested in taking a look at Buck, which is one of the key things about how we can move as quickly as we can, do take a look at it. It's open source. We've put it on GitHub, github.com/Facebook/Buck. There are loads of other open source projects that Facebook contributes to, and you can get them all from there. So, I mean, definitely do go have a look. So you've written the code. We wrote the code. We've compiled everything. We've got it going really well. Now, the problem is, you've only got a finite number of keystrokes in your life, right? If you do like 1 keystroke every second, which is incredibly slow, you've only got like, a certain billion keystrokes left in you until you die. You don't really want to spend those precious, precious keystrokes either writing emails or fixing bugs. It would be a lot more fun if you could just write features. How do we enable our teams to go faster by having to fix fewer bugs? We have pervasive testing. Most important thing, there is no QA department. Our developers write their own tests. They're the ones that are responsible for making sure that their software works. They wrote it, they should make sure it works. I mean, I can write software incredibly quickly if I don't have to prove it works, right? But it helps neither man nor beast. So the first set of tests we write are unit tests. These are small tests that run in a handful of seconds, or even faster, hundreds of milliseconds, tens of milliseconds. And there are 2 ways that we make this go as quickly as possible. Now, the important thing with Android, right, is you compile the code from Java, and then it takes the class files and it runs it through a process called dex, and that generates a DX file, and then that gets compressed into a jar file, and then that jar file gets sent off to a device or an emulator. Then the device or the emulator picks it up, verifies that the DX is OK, does some optimizations, and then finally it runs it. That's an incredibly slow process, even on a modern computer where it's got multiple cores and an SSD and things like that. So one way we can make our tests go a lot faster is to avoid having to compile down to DEX and get it onto a device. And for that, we use a framework called Roboelectric. Version 2 is actually really good. It's based on code from the Android open source project. And that allows us to run our tests on the JVM itself. We don't need to go onto the device. It just allows us to do that. And we use JUnit. Kent Beck works at Facebook. It would be rude not to use JUnit, because he wrote it. In order to allow us to stub out bits of the system to provide fakes and spies and doubles and indeed mocks, we use a library called EasyMock. That's just the standard we settled on. If you're writing software yourself, you could take a look at EasyMock. Mockito is incredibly popular in the Java space as well. But we do this. So unit tests allow us to get a certain amount of coverage. They allow us to have some confidence that the code works the way it should. But it doesn't give us complete confidence. And in order to get more confidence on top of that, we run larger tests. Notably, we're starting to ramp up our usage of a framework called Cellendroid. So Cellendroid is an implementation of the WebDriver APIs extended onto mobile, and that allows us to test a native app, hybrid app, so part native, part web-based, and just pure web-based, using the familiar WebDriver APIs. And so we can use the infrastructure that we built up for doing WebDriver testing to enable us to do mobile testing as well. When we run these, it looks like a majority of our tests are going to be running on emulators. If you are using an emulator, then Haxum, the extensions by Intel, and the x86 images allow you to go from something incredibly slow to something that in many cases is faster than an actual device. So emulators using x86 are really good. There's a new thing called Genymotion coming through, which looks like it'll be really, really interesting and super fast as well. But yes, so we write these end-to-end tests using Selendroid, and then that allows us to, and we've written frameworks on top of Selendroid that allow us to repurpose correctness tests, does this work, to also measure performance and other metrics that we care about, like memory consumption, CPU usage, network usage, things like that. So we can instrument our existing tests, and we can track when someone does something that causes a regression in user behavior. Because people never do anything that actually improves things, right? The state of the world only ever gets worse. Actually, I hope it doesn't. Those are the larger tests. So we've written code. We can go super fast writing our code. We know that the code we've written isn't garbage. So the final thing we need to do is get this code in the hand of users, right? It's not until you get the code used by a user that you can say that you've actually written this thing, right? Until that point, it's a fantasy. It's an agreement that we have that we're making progress, but until someone sees it, we don't know. So, boom. What we do is we've got 3 ways of putting code in the hands of users. For a start, everyone at Facebook can dog food the latest app. Are we all familiar with the phrase dog fooding? Yeah, it's where it comes from the expression eating your own dog food. There's a gentleman from Netscape earlier where I believe this phrase originated. And it basically means you take the software you write, and that's the thing you use day in, day out. So everyone at Facebook is using a build of Facebook for Android that's basically tip of tree, and that updates on a really regular basis, like every day. Now, Facebook isn't that large a company when compared to some of the giants of tech. There are approximately, 1,500, 2,000 engineers, and maybe a few more, twice that number for marketing, sales, and HR, and all the other functions. That's big, but it's not actually that big. And we're all relatively wealthy, and we all have a fairly limited range of devices. Like, very few of us voluntarily carry around a gingerbread phone, but gingerbread is still, 40% of the Android market? Still hugely, hugely popular. And so we've got an alpha channel and a beta channel. Now, these are done through the normal Google Play mechanisms. So if you want to sign up, you can. The alpha channel gets updated 3 times a week. I think it's Monday, Wednesday, Friday. And that allows you to get a cut of the tree that we think is relatively good. And at the moment, I think there's about 20, maybe 200,000, I forget the number of people, using the alpha build. And it gives us really good information. That lets us know that the features we're writing are stable or not, and are working more or less as intended. If you're not quite happy to live on the bleeding edge, but you'd still like advanced access to features and things like that, there is a beta program, and the beta program gets updated 4 times before we do a release. Our releases, because we've got all this infrastructure in place to enable us to go super fast, we can do a release basically every month, every 4 weeks. So when we're ready, what we do is we take our tree, we fork our tree, and we say this is the release branch. We spend 4 weeks stabilizing the build, soak testing it, putting it in front of people. The end of the 4 weeks, we ship. Now, this means that all the features we write have to be hidden behind feature flags or be designed in such a way that they're easy to pull out of the application, because we don't ever want to ship code that makes a user's experience of Facebook less than stellar. We'd like it to be as good as humanly possible. So during that 4 weeks, if it looks like a feature is still in churn, if it looks like it's still being developed, if it looks like it's not going to be as good as we hope it could be, we just pull it out. And because there's going to be another release in 4 weeks' time, it's okay. Like, people don't get really, really upset. I've seen projects that use a feature-based releases, and they can be particularly fraught because you spend all the features are ready except for one, right? And the entire release is held up as the engineering team frantically try and get this thing working, because they've been going incredibly fast and just trying to get this thing ready when everyone else is waiting for them. The quality isn't always there. So yes, we do time-based releases, and it enables us to be a lot more confident about releasing high-quality software. So that's basically how we build Facebook for Android. We've covered the source control that we use. We've covered the tools that we use for doing the building. We've gone through how we do testing, both the small tests and the end-to-end tests, mentioned some of the frameworks we use, and also covered our release process. I've got some time left over for questions, but thank you all very much for your time and attention.
Thank you so much, Simon. That was very cool, even for me. If I'm not 100% technical, but I got some very cool stuff out of it. Who would like to ask Simon some questions?
Hi. Sorry.
Wow.
Hi. Hi. I'm Vlad. I'm a mobile developer from MReady. Can you tell me a bit about how you come up with the idea for the chat heads, for the Facebook Messenger chat heads for Android, and what technical difficulties did you have?
So I'm part of the infrastructure team, so I could tell you how we build chat heads and how we do some of the things with that. But I'm afraid I don't actually know a lot about the reasoning behind it. I know that it was part of the Facebook Home effort, which is a chance for you to have a really rich interactive experience with your telephone. Like, when you're standing in a queue at a checkout, for example, it's really nice to just be able to sort of quickly have a look and see what your friends are doing, like something without actually having to go to all the hassle of unlocking your phone, loading the application, waiting for it to load, If you're interested, though, the library that we use for the Spring physics, when you drag a chat head around, that's been open sourced. If you go to github.com/Facebook, you can grab hold of that. I know that's not actually answering your question, but I'm happy to try and find someone who can answer that if that would be useful.
Okay, thank you.
Cool. Thank you.
Okay, we have a question over here.
Hello, my name is Ciprian. Question, you here presented the process you use for developing the Android version of Facebook.
Yeah.
What about the other platforms, iOS, Windows Phone? Are there any major differences and something that you do differently than for Android?
I can speak to the iOS code base. iOS, again, the iOS code is all stored in a single tree. We use Xcode instead of IntelliJ, obviously. Why would you do any work on iOS without using the Apple tooling? So we use Xcode, which means the projects are slightly different. We don't use Buck on iOS yet. We're working on it. But we have got a tool called XCTool, which you would use in the same place that you'd use Xcode build. But it's a bit faster. It does far cleaner output. So when you do a build and a test fails using Xcode, you get like pages and pages of gumph and like stack traces which are impossible to parse. XCTool actually presents that information in a far more readable format and far more actionable format, so you can go and have a look at it. And it also does some basic analysis of the tests that it's running, so it attempts to run things in parallel. Like Buck will just scale up and use every single core in your machine. Xcode build doesn't do that, and XCTool attempts to make more efficient usage of your infrastructure. Again, that's open source, so you can go grab it and have a look at it. Yeah.
Thank you.
Very cool. Next question.
I'll just repeat your question for the audience.
Yeah, okay. Radu Mihaiu, Kidzopia. I was wondering if you're using any agile development tools or something like that.
Sure.
And if so, if it's Scrum or Kanban,
So,
could you develop a bit on this subject?
yeah, the software development process at Facebook, the only thing that you need to do is check into Git and make sure your code is reviewed. And then the individual teams can pick how they're doing things. Now, the teams tend to be relatively small. My team is 5 people large, and that's not an unusual size. So we've got really good collaboration within a team, and we own our features. So it's an engineering-led culture. Like those features are sort of developed bottom up.
How do you sync with other teams? Because usually teams are small,
Yep.
but the problem is how do you sync, 3-4 teams working on similar processes or,
Sure.
product?
Well, it involves a certain amount of communication. Got to talk to people, right? Generally, the people who are working in your area. With Fabricator, there's a tool. It's got a feature called Heralds, so you can keep an eye on parts of the code base and be alerted when people are landing code in there. And generally, it's well known that a certain group is an expert on a certain feature. So although like the photos team, which is quite big, may be working on several features, they're all part of the same team and they can all communicate and they're all aware of what they're doing. And then there's sort of cross-feature communication that's done on some of the mailing lists. To get back to how do we actually write software, each of the teams can pick what they're doing. My team tends to lean more towards an XP-ish flavor, so we try and do TDD. We try and write code that way. Other teams tend to just write code the way they want to and what they think is a good idea.
Thank you so much. Unfortunately, we're out of time for questions, but you can catch Simon in the during the coffee break. Thank you so much.
Thank you very much. Thank you.